Hello everyone. Today I am going to discuss about pure electrical vehicles. In my previous video, I already discussed about what is EV, how it works, and the level of electrifications and the powertrain architectures, key components of a electrical vehicle. Also, we have discussed about the different type of batteries, different type of motors used in electrical vehicles. Today, we are going to see pure electrical vehicle architecture, what are the internal circuitries available, how it is connected, how it works, we are going to discuss. Let us start. Before that, let us have a small quiz or question to answer. So, which EV powertrain architecture has a better fuel economy in the below option? This topic I have covered in the previous video. If you have watched the video, you will get the answer. Otherwise, if you know the answer, please let me know in the comment box. So we have the option A, battery electrical vehicle, option B, hybrid electrical vehicle, option C, PHEV, option D, FCEV. So which is the correct answer? Please let me know in the comment box. Let us start the topic for today. BEV, battery electrical vehicle. It's very simple. This vehicle is taking the power source from the battery. So that means it is going to convert the electrical energy into mechanical energy through the motors, and which will be connected to the axle of the drivetrain, and the vehicle is going to run. So the battery is going to store the electrical energy from the external power supply through the charger and the charging port, and this electrical energy is given to the inverter. The inverter converts this DC supply to AC. The required voltages will be maintained through this, and it will be given to the motor, AC motor. Either it may be a permanent magnet motor or it may be an induction motor. So the motor converts that electrical energy into mechanical rotational energy, and this rotational energy will be connected to the drive shaft, and the motor drives it, so the vehicle moves. So the speed of this motor determines how much fast the vehicle moves, and the speed of the motor will be determined by the frequency of the supply given to this motor, right? We will see the main parts of battery electrical vehicle. If you see this picture, you can easily understand the major components involved in the BEV. So let us start from the charging port, where you are going to connect the supply, the AC supply from the utility or the charging point. And from this charging port, the AC supply will be given to the onboard charger here. So this onboard charger is going to convert this AC into DC, and the voltage levels will be maintained according to the voltage level of this battery, high voltage battery, and it will be sent through the contactor. Through the contactor, it goes to the battery bank. So once the battery is receiving the power, it starts charging. And after this, we have IVT smart shunt, so which is going to work as a measurement device, which is going to continuously measure the current and voltage given to the inverter and other accessories. And other important components in this picture, we can see the cooling pump, which is going to help us to keep the system in the cool condition. And we have 12 volt battery, which is going to drive the low voltage or LVS system. And we have the inverters, so which is going to drive the motor. So the inverter takes the high voltage DC, and which is going to be converted into AC, high voltage AC, and it is going to be a variable frequency AC. So based upon the requirement of this motor, so the voltage levels will be maintained, and the triggering signals will be coming from PDU-8, so which is nothing but a power distribution unit. And we have the master controller unit here, VCU 300, and which is going to connect all the CAN bus networks, and PDU, power distribution units, and also it is going to connect to the external device like a computer to monitor the parameters. And also we have other devices or equipments like a CD carbon digital dash, which is going to show you all the parameters while you are driving the car, and DBW pedal, so that is drive by wire pedal, and CAN keypad, and we have two contactors to connect the high voltage battery to the inverters and other equipments. And apart from that, another important system or equipment in this BEV, you can see this is a battery management system. So where we have BMS master and BMS satellite 1 and 2. So this is the major parts of any BEV system. So BEV topology you can see here. So the battery pack is available here. So it will be a high voltage battery pack. And from there, high voltage DC supply is given to three-phase power inverter, which will convert this high voltage DC into high voltage variable AC. And from here, it will given to the drive unit so that the motor runs, so that the vehicle moves. And we have DC to DC converter, which is going to give low voltage supply to the battery, the low voltage battery, and also it is going to provide required voltages to different equipments in the EV. And electric AC compressor, which is going to operate it from the high voltage DC, and HV cabin heating system and battery heating system. So these are the different systems which is connected in this BEV topology. So BEV architecture, we are going to have different architectures. So central drive, so this central drive architecture is going to have the driving wheel and the driving shaft, and the differential, you are going to have a fixed gear, and these two wheels is going to just a free run. So we have a battery here, so which is going to drive the motor through the inverter, and then fixed gear. So this gear is connected to differential, so that it is connected to drive shaft, so that it is going to drive this driving wheel. So this is one architecture. The another architecture is the one which is having the motor and wheel together combined in a single system, and the battery is connected through the inverter to this motor come wheel setup, so that it is going to drive directly from there, and it is going to move the vehicle. So this type of architectures are used in electrical scooters in mostly. And BEV architecture will have drive derivatives. It can be in the other method as well. So the battery is available. So two motors and fixed gear arrangement and driving wheel. So this is one type of architecture. And the other type of architecture, we have a battery and two motors here, and it is connected in this way: fixed gear, drive shaft, and driving wheels. So this is a Mercedes-Benz type of vehicle. So it is architecture is given here. How the EV is going to work, or it is going to operate. So during acceleration and braking, so I am just going to divide into two parts. Acceleration time, what is going to happen? Battery is going to provide the AC motor through inverter. So means the battery is going to provide the power to the AC motor through inverter. So this is going to be a variable frequency supply, so that it can change the frequency and the speed of the motor. And the speed of the motor is controlled by varying the frequency of the inverter output. This is what I said now. And during braking time, what is going to happen? The motor becomes generator and produce a power and send to battery through converter unit. So this will be a regenerative braking. So EV electrical system has three major components. One is high voltage system, another one low voltage, and multiple CAN networks. And apart from that, we have a BMS system. So let us see what is the high voltage system. What are the major components in a high voltage system here? So you can see in the yellow color line, whatever is highlighted here. So this is a high voltage system. So where you have a charging port, which is going to connect to the charging point, and where you will get the AC supply from the grid and will be connected to the charger, onboard charger here. So this onboard charger is going to convert this AC into high voltage DC, and it is going to connect through contactor to the battery. So the battery is going to deliver the power to the inverters here. You can see this contactor is going to deliver the power to the inverter, and this contactors are going to controlled by this PDU unit. So there is a power distribution unit, and there is one more contactor here which gives the supply to this measurement device. So this is a IVT shunt, smart shunt, so which is going to measure continuously voltage and current, which is going to the inverters and other system. And if you see this motor inverter, so if you have two different motors, we are going to use two more inverters. If you have only one motor, then we are going to have only one inverter. So the purpose of this inverter, as I told you earlier, is going to convert this high voltage DC supply into variable AC supply, so that the motor can run according to the frequencies, so speed can be changed. So this is about the high voltage system. So let us see.
High voltage, or HV systems, are supplied by a high voltage battery, typically over 200 volts.
So this is the high voltage battery pack.
And includes contactors.
We have a contactor
from the battery to the high voltage components,
which delivers
like
the power to the inverters, motor inverters.
Converter. An onboard charger is used.
And this is the onboard charger which converts the AC into DC,
to
high voltage DC, and charging point also shown
battery.
here. In this, the key terminologies used here is IVT. So this is a measurement device which is going to measure current and voltage continuously, and it is going to communicate this information to the controller using CAN bus. And the second one is a DBW, so that is a drive by wire. So you are going to control the vehicle just by giving the electrical signal through this D by W. So DBW technology in the automotive industry is the use of electrical and electromechanical system for performing vehicle function traditionally achieved by mechanical linkages. So in the IC engine, so we are going to use a mechanical linkages. Here we are going to use a DBW. And the second system is a low voltage system. This is very similar to the normal conventional system. So where you have the battery, low voltage battery, and the lighting arrangements. You are going to have the lighting arrangements in the rear and front, and the sensor units, which is going to give a different sensing for safety mechanisms, and reverse cameras, and so many other things which is going to be driven by this low voltage battery. And this low voltage system is going to be controlled by this PDU unit, so which is going to give the signal for controlling this control cooling pump, and the motor inverter is going to give the control signal from this PDU unit. And also we have PDU 8, so which is going to connect to the keypad, CAN keypad, and also we have a dashboard which is going to be displaying all the parameters to us, so the speed and fuel level and all those things. And so these PDU units, these two PDU units is going to give signal to headlamps. Here we have rear lamps, and here we have headlamps, and then this contactor is going to get the control signal from this this PDU unit. And so these are the low voltage circuit, and let us see one small animation for this as well.
Accessories and the like. One of the many advantages of EV conversions is the ability to retain an internal combustion engine vehicle's existing low voltage system.
We have low voltage battery here,
DC converter converts power from the high voltage circuit to charge
and
the 12
which is going
battery,
to provide the
which supplies power to
required signal to all the
ancillary
sensors,
devices.
as I told you
But
earlier.
these devices still require a method of control, and unless you want to rewire your low voltage accessories to individual switches, we've created a more elegant solution in our PDU-8
We have PDU-8, so power distribution.
A great thing about CAN bus is it allows you to control 12-volt switch devices
we have two more
with
PDU
our VCU
units here,
using PDU-8 power distribution modules placed strategically throughout the vehicle. PDU-8, connect your PDU-8
So
to the
these PDU
VCU
units are
using a simple
connected to
two-wire CAN
the
connection,
controller
and then
unit
program
here
and control their
through the
functions
CAN bus,
using AMCAL
and also
software
it is connected to
for
the
the VCU.
software. So
These
where you
small,
can see
robust
all the
units can be
parameters in the
daisy-chained to control
software.
multiple switch devices, allowing you to place them closer to the functions they're
So we have a
controlling
lot of
for easier
closed loop
wiring.
system here,
And since
and
the
this closed loop
programming is
system
done
is
in the VCU,
continuously
there's
monitored
no need to
through
carry
these
dedicated
PDU
spares
units,
for each
which is
module.
going to be
At
connected
the
to the
rear of the
controller
vehicle, you can
unit.
see a PDU-8 that is programmed
So
to
this PDU
activate the
unit is
inverters and the cooling
controlling the
pump, and
inverter
control
as
the
well as the
activation of the
cooling
taillights,
pump
blinkers, and reverse
and the
lights.
lamp,
A
which is
second
connected in the
PDU-8
rear.
near the
And
front
this PDU
passenger
unit,
seat
as I told
footwell
you
controls
earlier,
the
is
CAN
going to connect
keypad
to
and
the
digital
CAN
dash
keypad as
display,
well as
while two
a
additional
digital dash.
PDU-8s
And
at the
these two
nose activate the
PDU units are
contactors for
going
the
to
high
give the
voltage
supply to the
system and control the
contactors and the
headlights.
lamp. The next important part is a CAN network, so which is going to act as a communication network for this EV system. So we have a controller and other accessories like PDU units, and the PDU units are connected to the motor inverters and the cooling pump and all those things. So all these will be connected to this microcontroller based VCU 300, and this VCU 300 is going to connect all these PDUs through this CAN network. So one network is connected to PDU-8 motor inverter, and then we have this one cooling pump, all these things in one network, and another network we have this IVT shunt and PDU-8, which is going to have control over this contactor and these two lamps. And the third network which is going to connect to this external device, where you can connect to the software and you can see the performance of each and every components of this EV. So this is about the CAN network, so which is used as a communication device. So that's it about the battery electrical vehicles. So if you have any doubts, please let me know. Thank you for watching.